right, in class today, we started looking at chemical equations. And before we start looking at chemical equations, we have to look at something called the law of conservation of matter. And this should sound familiar. In the law of conservation of matter, conservation means to save. Matter, has mass and takes up space. So the law of conservation of matter states that during any change, I'll say any physical or chemical change. And let's talk real quick right here about the difference. This was a lot of middle school science, a lot of elementary school science. You learned the difference in physical and chemical changes. Physical changes are when you melt something, or you boil something, or you crush something, or you cut something. You're not creating anything, well, not say creating, but you're not transforming that into something new. If I have a glass of water and I freeze it, it's still water, it's just in the frozen form. So chemically, H2O is water in the liquid form, and H2O is the ice too. It's in the solid form. So that would be a physical change. So you deal a lot of those in elementary school. In high school, we talk a lot about chemical changes because we're preparing you for chemistry. So chemical changes are why we have these down here, these chemical formulas. So what it says, a chemical change is when you have two substances or more sometimes, and it goes through a change, or you might have one substance and it changes into something with its own unique properties. You have something different than what you started with. So it's not creating something new, but it is transforming the matter that you once had into something that is unique and different from what you started with. So again, H2O in a liquid form, and once I freeze it, if I melt it, it just comes back to liquid water. That's a physical change. Chemical change would be if I took water and I put electrodes in it and I broke it up into oxygen gas and hydrogen gas, and I broke it into those two sections, I would have something totally different, and then I couldn't just recombine them without going through another chemical reaction. So physical change and chemical change. So again, we're going to be dealing with the chemical part. So during any of these changes, but we're talking about chemical, matter is never created or destroyed. So nothing goes missing and nothing is being made out of thin air. But it can be transformed. And that's what we're looking at there, especially in the chemical change. Can be transformed. All right, so what we did today is we started looking at chemical equations and we talked about their parts. You have two parts. You have reactants and you have products. So in this case, I have this section here. Those are my reactants, okay? And this one here, that would be my product. That's what's being produced. And this sign in the middle here is a little arrow, and it's always a little arrow, and this is called the yields sign. It's called yields. It's kind of like the equal mark for chemistry, so yields. So what happens is we decided that we were going to make models, and we use construction paper, and we use different shapes and colors. For mine, I used red circles to show nitrogen. So I used all red circles for nitrogen. You don't have to use red circles. You could use yellow triangles or green diamonds or whatever. But in this case, I made a nitrogen molecule, and I'm going to make those touch because N2 means I have two nitrogens bonded together. Okay. Plus, the next part says I have two H2 molecules. Okay, two H2 molecules. So I used yellow squares for hydrogen. So that's an H2 molecule right there. And the big 2 in front of it tells you how many molecules I have. So in this case, I have another molecule because I have two H2. You notice in front of the nitrogen, I only didn't have a number. And that means I only had 1. So I had just an N2. So that's 1 N2, and I have 2 H2s. Okay? And then I've got something called my yields. Okay? it's going to yield, it's going to give me 2 NH3s. Okay, well, an NH3 is ammonia. There's my nitrogen, and my nitrogen is bonded to 3 atoms of hydrogen. So my NH3 looks something like that. And notice I've got a big 2, so it has another one. So I had 2 NH3s. Okay. So now we come down here to this part, and it says list your elements involved in the reaction. Well, I only have 2 elements. I have nitrogen, that's my red circle, and I have hydrogen. So the number of atoms in my reactant over here for nitrogen, I'm just looking at nitrogen, is I have 2. 2 atoms. I'm counting the atoms. So I have 1 molecule, right? But I have 2 atoms in that molecule because it's an N2. So I have 2 atoms of nitrogen. On the right side, every time I see a red circle, that's an atom of nitrogen. So I have 2 atoms of nitrogen over here. Okay? Hydrogen on this side, look here. I'm counting just on my reactant side because we're looking at the reactants. And then we're looking at the products. I have 4 on this side because I've got 1, 2, 3, 4. And on this side, I have 6. 1, 2, 3, 4, 5, 6. So when I look at my nitrogens, they balance. When I look at my hydrogens, they don't balance. I've got 4 in my reactants, and I have 6 in my products. So something's wrong with this equation. So I'm going to have to balance this equation. So what do I need? Well, I need in my reactants on this side, I need 2 more hydrogen. So I can fix that. I can get me 2 more hydrogen and put them in there. Then I have to note that. So here, how am I going to show you that I added another hydrogen molecules? I'm going to change that to a 3. Okay? And if I change that to a 3, I now have this as a 6. And that is exactly what I want. So when everything is balanced out, my number of atoms on my reactant side is equal to the same number of atoms of the elements on my product side, then I have what you call a balanced equation. So when we look at the back side, we did this in class together. You can see where I've kind of already started. You've got 2K, which is potassium. So there's a potassium. Cl, which is a chlorine. O3. So there's a Cl and an O3. This is, you notice that it starts with 1 molecule. Oops. And it really doesn't matter how they're not perfect. So I have those kind of in a grouping. And I have 2 of those. You see that? I have 2 KClO3s. So I need to do that again. I've got another potassium, and this is called a chlorate. It's a polyatomic ion, but we don't have to really know that. But I do need to know what it's telling me. I do need to be able to make them. So see that I've got 2 potassium chlorates on this side. Okay. And then this is a decomposition reaction. It's going to break down into 2 parts. So those are my reactants. And then my products on this side is going to break down into 2 potassiums chlorides. I have lost my... There's 1 potassium chloride. Here's another one. Here's my other potassium chloride. So you can see here I've got 2 potassium chlorides. So I've got a KCl and a KCl plus, you can see I've got 3 O2 molecules. So an O2 molecule is going to look like this. And I've got another O2 molecule. There's O2. And then I have 3 O2s. So there's another O2 right there. So when I model this, that's exactly what I see. So when I go to count up to see if this is balanced or not, I've got 3 elements. I've got potassium, I've got chlorine, and I've got oxygen. So in the reactant, remember the reactant's on the left side, okay? I have 2 atoms of potassium. On the right side, on the product side, I have 2 atoms of potassium. For chlorine, I'm counting my red squares in this case. Chlorine, chlorine, that's 2 in the reactants, 2 in the products. My oxygen, I've got 1, 2, 3, 4, 5, 6. 6 in my reactants, 2, 4, 6. So this one is balanced, and that's all I had to do. So now I've shown a chemical equation with 2 molecules of potassium chlorate, which decomposes into potassium chloride, 2 molecules of potassium chloride, plus 3 molecules of oxygen. And that's what it is. So what I want you to do is try to do this 4P on your own, and we did this in class, and we just use the same thing. You can use any shape and color you want, and again, up here with these, you can pick and choose if you wanted to do orange circles for one of them. It doesn't matter the shape and color as long as they're the same. So whatever you choose for potassium should look the same here and there. It doesn't have to be exact, but should be the same color and basic shape. Okay? So whatever I choose for oxygen on this side, I don't want to choose, you know, green squares on this side and blue diamonds over here. I want them to match. So all my oxygen should look the same, whatever that is, and that's what we wrote the symbol on there. So that is how to make a model of a molecule, and then tomorrow we're going to start looking at how to balance chemical equations. All right? That's that.